Well, let's talk about something that's happening literally all around you, right at this very moment. Energy efficiency. It's kind of this invisible force that decides how much work our gadgets actually do versus how much energy just, poof, turns into wasted heat. It's a huge deal. So let's dive in.
I mean, you know the feeling, right? You've been scrolling through videos, maybe playing a game, and you suddenly realize your phone is getting warm, maybe even a little hot. Well, that heat, that's the star of our show today. It's the biggest clue that not all the power from your battery is actually running your apps. Something else is going on.
So here's our game plan. We're going to follow that trail of lost energy, first figuring out where it's escaping to. Then we'll learn how to actually put a number on it using a super simple formula. After that, we'll check out ways to be more efficient. And finally, we're going to bust the big myth about a perfect 100% efficient machine.
All right, so first things first, no device is perfect, not a single one. Every time energy changes form, like say electricity from the wall turning into the light from your lamp, some of that energy always gets away in a form we didn't want.
And there's a name for this escape artist. It's called dissipated energy. All it really means is that the energy spreads out into a less useful form, which is almost always heat. Now, it's not truly lost, physics won't let that happen, but it just heats up the device and the air around it, which, isn't very helpful when you're just trying to charge your phone.
Let's make this super clear. Think about an electric kettle. The useful energy is what's heating the water for your tea. The wasted energy, that's the kettle itself getting hot. Or a light bulb. Its job is to make light, but man does it get hot. That heat is just wasted energy. Same with your TV, the light and sound are what you want. That warmth coming off the back, yep, that's dissipated energy. Okay, so if every device wastes some energy, how do we compare them? How do we know if one light bulb is better than another? Well, we need a way to measure it. We need to put a number on this waste. And that's exactly where the idea of efficiency comes in.
At its core, efficiency is just a score. It tells you what percentage of the energy you put into a device actually comes out as useful work. That's it. A higher efficiency score means less waste, and that means a better performing device.
So you've got these two extremes, right? On one side, you have a highly efficient device. It's a star player. Almost all the power it draws goes right into doing its job. But on the other side, you have a highly inefficient device. It's a real energy hog, wasting most of the power it's given, usually by just getting really, really hot.
Okay, time to turn this idea into an actual number. And don't worry, the math here is super simple, but it is so powerful for understanding what's going on with your gadgets. So let's check out the formula.
Here it is. It's just one thing divided by another. The efficiency is the useful energy you get out divided by the total energy you put in. Basically, what you wanted to happen divided by what it cost you in energy. And both of these are measured in joules, which is just the standard unit for energy. It keeps the math nice and clean. Okay, let's put this formula to the test with a real example. Imagine we've got a modern LED light bulb. We plug it in and it uses 140 joules of electrical energy. In return, it gives us 108 joules of useful light. The rest, of course, becomes wasted heat. So, how efficient is this bulb?
It's really just a few simple steps. First, you pop the numbers into the formula, 108 divided by 140. Your calculator will spit out a decimal, in this case, 0.77. Then, to make it easier to understand, we just multiply that by 100 to turn it into a percentage, which gives us our final answer.
And there you have it. This LED bulb is 77% efficient. That means more than 3/4 of the electricity it uses is turned directly into light. Only about 23% is lost as heat, and for a light bulb, that is fantastic. The old-school incandescent bulbs, they were often less than 10% efficient. Just think about that difference.
So, knowing the score is great, but how do we actually improve it? How do engineers design things, from cars to computers, to waste less energy from the get-go? Well, it really comes down to fighting the two biggest sources of waste.
You've got two main weapons in the fight for efficiency. For anything with moving parts, like an engine, the enemy is friction, and the weapon is lubrication. It just lets parts slide past each other more easily, creating less heat. For anything dealing with temperature, like your house or an oven, the enemy is heat escaping, and the weapon is insulation.
Now, to really get insulation, we need to talk about something called thermal conductivity. It sounds complicated, but it's just a rating for how easily heat can travel through a material. If something has high conductivity, heat zips right through it. If it has low conductivity, it's great at stopping heat, it's a good insulator.
And whoa, just look at this chart. It shows you everything you need to know. Look at copper way up there with a score of 385. Heat loves to travel through copper. But then look at brick. It's just 0.15. And then there's air. It's all the way down at 0.024. That's almost nothing. This is exactly why things like double-pane windows work so well. They trap a layer of air, which is a fantastic insulator because it's so bad at conducting heat.
We've been talking about getting more and more efficient. So the obvious question is, can we get all the way? Can we actually build a perfect machine, a device that hits 100% efficiency and wastes zero energy? Well, according to the fundamental laws of the universe, the answer is a hard no.
This is a big one. It is a non-negotiable rule of physics. You can't ever get 100% efficiency, and you definitely can't get more than 100%. And the reason why goes back to one of the most important rules in all of science.
I mean, just think about it for a second. If a machine was more than 100% efficient, it would mean you're getting more energy out of it than you put in. You would literally be creating energy out of thin air. And that, well, that breaks a very, very big law.
And this is the bottom line. It's called the law of conservation of energy. Energy can't be created or destroyed. It can only be changed from one form to another. So every single joule of energy you put into a system has to be accounted for. Some of it does useful work, and the rest gets dissipated as waste. You can never, ever end up with more than you started with. So there we have it. We went all the way from your phone getting a little warm to a fundamental law of physics. The next time you feel a gadget heating up, you'll know exactly what's going on. That's the price of doing work. So I'll leave you with this to chew on. Now that you know how to spot it, what do you think is the most inefficient device you use every day? You might be surprised.